Hello, this is Andrew Walensky. My presentation will be on considering GI science as an academic discipline. Um, some forewarning here. I don't anyone freak out. It's probably a strange title given what we've been working on so far, and some things may seem like I'm undercutting what we're studying all in the same program, but I assure you that's not the case. But it's a really interesting topic, and I hope everyone enjoys it. So we'll get started. The first question it's a very valid one. Why does this matter? Why does it matter if GI science is its own academic discipline? Does it have any real effect on me? The answer is yes. Perhaps surprisingly, there are social, moral, and economic benefits to being a legitimate discipline. This translates into funding opportunities. It also translates into a sense of belonging in academic circles. And it affects the quantity and quality of funding opportunities. So being recognized as a legitimate area of study is super important because it not only ingrains you into the academic sphere, but it also allows others who aren't necessarily part of the discipline to recognize and say, hey, I know what this is, I understand it, I know it has a big impact. So to have a sense of belonging and to have funding opportunities are really important for the longevity of an area of study. And so there are three central questions before we can address the final one: is GI science a discipline? So the first one is, what is a discipline? This one's going to get pretty far away from our normal GI science track here, and it's going to get more into the philosophical and positivist mentalities of knowledge production, which is really interesting stuff, and hopefully gives some good perspective for everyone listening. The second question is, what is GI science? We're obviously all getting a master's in this. It's probably good to actually really understand what it is, because it is not practicing GIS. That much is abundantly clear. However, a lot of what we're going to see is that it's kind of pitched as that. GI science and GIS are both forms of, quote, doing GIS, and they're very different forms. And there's still an ongoing discourse, which we'll get into a little later. And the big question is GI science a discipline? Obviously, I'm coming at this from a certain perspective. You can believe what you want at the end of it, but I'm coming at this from some framework to try to analyze this on the whole. So hopefully you don't hate the results. So, the first thing, what is a discipline? There is a ton of documentation and research into this. It mostly started in the 1960s, and this came from, I believe, it was Sherman's work, 1962, and it was a 5-pronged method, saying that for something to be a discipline, it would have to have time-tested works. In other words, it would have to have rules and laws that withstood the test of time and were fundamental to the discipline. In biology, you have evolution. In geology, you have geologic time. In physics, you have general relativity. These are things that are really crucial. And in geography, we have Tobler's laws of geography. But again, that's the question, and we'll get into this a little later. Is geography and GIS different, or are they one's an extension of the other? But we're getting a little ahead of ourselves. The second part is a discipline-specific set of research methods. Again, this means that the discipline or the field of study has its own unique lens to look at the world, and that unique lens is informed by unique research methods. The third one that Sherman said was a defensible and intimate connection to human activities. In other words, this matters. Matters to people. Sherman's really highlighted that, and his early notions of discipline were really informed by this. 4, a multi-generational tradition. In other words, you have a history of practitioners and scholars who are actively contributing to the discipline. And then the 5th one is achievements by individuals and subject. So, for instance, if you go back to physics, that would be like you can go to Stephen Hawking or Albert Einstein, saying those are 2 icons. But not only that, but there's also an evolution, a progression of the ideals and the notions of physical laws. So that's what the early work focused on, and this changed considerably. Shermis has emphasized the connection to humanity. This has kind of not been lost, but in many ways, since so much stuff is digital now, making that clear definition of how this relates to humanity and the progression of human society and civilization is kind of been pushed aside. A big one was the idea that there's been some etymological studies of the word discipline and where it come from. And one of the big things they found is that a discipline should discipline its users. In other words, if you had been disciplined by your discipline, if a biologist has been structured and their way of thinking has been modified by the notion of a biological framework for knowledge production, that characterizes a discipline. This is a very meta way of looking at it for sure, but it's one of the crucial ones that since the 1980s and 1990s this one's been really important. The biggest thing now is the emphasis on how institutions. Disciplines are institutionalized. In other words, there are academic institutions and professional institutions which legitimize the work and the research being done. A subset of that is how to get your notions of disciplines from how institutions, academic institutions, draw the map of knowledge. What this means is, do they make separate departments? This has been an ongoing framework that statistics has been looking into. Statistics, that's another field of study that is kind of in flux. Are they its own discipline, or are they just under mathematics? Are they different enough that they could have their own department? And that's the way folks look at it. This has been kind of frowned upon because this means that institutions hold the power to say what is and isn't a discipline based on the need for it. The reality is colleges and universities will largely only offer things that get enrollment. If no one's going to study some obscure discipline, then that could mean that the discipline fades from existence. There is some truth to this in that disciplines a lot of times are viewed as deriving their legitimacy from their market value. In other words, how do they positively contribute to the market? This has been a free market approach that's been adopted in the early 2000s. There's also a thing called a deflationary approach. This one is where they worry not so much about what the discipline is, but look at the bodies of knowledge and don't try and label things. This means that if we look at GIS, for instance, or GI science, that GI science isn't a standalone discipline, but rather it is an amorphous blob that keeps evolving and changing, grasping at other disciplines, and there's a lot of overlap. The issue with this approach is that it's not very compatible with how institutions work. You can't just have amorphous departments that are constantly changing and pulling in new people, bouncing people around, bouncing research. It would be chaotic. There has been an increasing effort to try and divorce practitioners from academics. And what I mean by this is make the discipline about the academics, make the profession about the practitioners. There's been a lot of effort in the GIS community to establish a profession, and we'll get into that a little later and the consequences of that, but that is something to keep in the back of your mind. For our purposes, we'll use the six-pronged. It's a modification of Shermis's and some other later works. I think mostly Shermis, Goodlad, and I think Besher and Trowler, if I remember correctly. Or it might be Brady, but it doesn't matter. Citations are all going to be in the paper associated with this, which probably is a little sprawling. It may get a little overwhelming, but everything's there. The six things has a unique and definable body of knowledge. In other words, it's not already taken. It's something new that's studying, and it's significantly different from the existing disciplines or areas of study that it would qualify as its own. Leverages subject-specific methods, pretty self-explanatory. Maintains time-tested fundamental principles. In other words, it has some sort of fundamental premise, fundamental questions it's trying to ask. Has been formally institutionalized. This is the biggest one. Has it been adopted in universities, and is there a structure for new knowledge production and practitioners and academics? Number 5, maintains an academic journal. 6, community of practitioners and scholars. So now to the second part of it. What is GI science? In other words, what is our degree in, or what's this supposed to be in? In 1992, Goodchild and Goodchild's obviously a prolific geographer and a GI scientist and advocate for all things GIS. So unsurprisingly, he's cited throughout this entire paper and presentation. But he originally defined it as a subset of information science that is about geographic information. In other words, he said that GIS is significantly different from basic information science insofar that spatial data is special. And it originally he envisioned this as a two-pronged approach. GIS is a toolbox, saying a geographic information system is a tool to solve other disciplines' problems, and also GIS, a geographic information system, is a research object. Together, he said this makes up GI science. Perhaps unsurprisingly, this geographic information systems have changed, and so too have our notions of GI science. Today, obviously, GI science is still evolving, and so I want to make sure that today is apparent that this could change in a couple of years even. Andrew Frank was another prolific thinker in GI Science's foundation. He originally said, a geographic information is a spatially enabled database. In other words, it's a special type of structure that can handle spatial data in such a way that geographic analysis can go through. He came out with that, I think, in 1988 when he first said it. He had a 2012 paper where he and Chrisman and Tobler even all talked and debated about this stuff. It's really interesting. But he says it evolved into a spatial time machine. In other words, a GIS is now something that can recreate past, present, future, and potential realities. And so he said, it changed really considerably. And what this really stems down to is that GIS science is a product of a really strong push in the 90s and early 2000s to make GIS qualify in terms of what we understand as a profession. This was led by Michael Goodchild. And so this led to a lot of efforts to make standardized curricula, unifying principles of what GIS is based on, what is the fundamental questions of GIS, and this stemmed from, is GIS science a mathematically centric discipline or field of study, or is it, like I said before, a deflationary field where it's constantly changing? But the core issues of GIS science, and perhaps it is better defined by the issues it tries to address rather than what it is it tries to translate infinitely complex phenomena into a digital form. How can we translate landscapes and climates into zeros and ones and accurately analyze that in a system? The storage and simplification of data structures. I don't know if anyone ever here has really cracked open databases, but they're incredibly complex, especially some of the more obscure ones. I mean, if you get into, not obscure necessarily, but obscure Postgres, I mean, some of the structures there are phenomenal and beautiful, but they're really intense. There's also, I don't have here, but the aesthetics of data, how data looks, how data appears. That's really important. And then the biggest one, I think, and this is obviously up to the individual, the theory-based discovery. In other words, can we study a generic, quote-unquote, GIS? I know we've been working with Esri products predominantly, but there's a lot out there. Esri only has a 42% market share of the GIS usage in the world. A lot of it in Europe is open source, OGC compliant data sources. Grass or not. What are some of the other ones? GeoServer. But so all the work we've been doing mostly in this program is through Esri's platform. But that necessarily isn't actually GI science. And so we got to here. So we have our definition of what GI science is or what it tries to address. We have our notion of what qualifies something as a discipline. How do we translate that into each GI science discipline? Unfortunately, the animation, since I don't have PowerPoint installed, got pulled away here, but we'll keep going. 1, does it have a unique and definable body of knowledge? This isn't clear because the biggest thing is, as I said before, GI science is easier defined by its core issues rather than what it is. And so there's still an ongoing debate of what GI science is in terms of its definition, and so it's kind of hard to say where the body of knowledge ends. Is it information science that has a spatial angle? Is it geography? Is it basically digital geography? Is it data science with spatially enabled data? Is it a branch of computer science? Since there isn't a clear consensus on what GI science is per se, it's it's unclear that if there is a definable body of knowledge. If, however, we go on to say that this is basically digital geography, then yeah, I would say that the problems that GIs attempt to solve and the problem that GI scientists attempt to solve in evaluating, understanding geographic information systems is super, super important and super, super legitimate, and that would. So this one, it's like a maybe. Unclear, but probably maybe. There's a tendency in when you're drawing academic lines to ebb on the side of no rather than yes. So we'll call it a maybe and say, it's a soft yes, maybe a no. Leverages subject-specific methods. Again, this is dependent on what we understand GI science to be. Is GI science a subset of information science? Is it a subset of geography? Is it a subset of data science? Is it a subset of computer science? Or is it some sort of hybridization of all those, which makes a unique body of knowledge? If it does, if we do say, hey, it is a unique area of study, then yeah, then we can say, looking into functors and simplices and vertexes and how you can have different, your data can be represented by different forms and how we can analyze that, then certainly that is a subject that is subject specific. If, however, we take a more deflated approach where it's pulling from everything else, then it probably doesn't have subject specific. We're supplying the work of other disciplines into a geographic lens and calling it its own. It maintains time-tested fundamental principles. Not yet. Obviously, GI science and GISs are super new. Tobler came out and said, I think it was in 1980, that in 20 years, 50% of the stuff he taught would be obsolete. Andrew Frank and Chrisman came out in 2012 and said, hey, in 20 years, we think that 10 to 20% of what we teach will be obsolete. If that's the case, there's a lot of turnover in what we understand to be true with the geographic information system, and so that certainly is not maintained. The biggest one here has been formally institutionalized. So this one I had to do a good bit of research. There are 695 public institutions in the United States, excluding territories. I decided I want to do some statistical analysis to get a 95% confidence interval with a 5% with 5% confidence around that. So basically, it's either 100 or 90. It's in between 90 and 100% correct in terms of its representativeness. I had to do 298 colleges. I looked at each of these colleges and looked at do they have a GIS program? Do they have a GIS department? Do they offer certificate programs or graduate programs? And so here we have it here. So 89 of those schools, so but just 36% had geography departments. 17 had GIS majors, and a GIS major I considered as not being, you major in geography and have the option to go to the GIS track. Because again, if we assume that's true, that means that GIS is certainly not, GIS science is certainly not its own discipline. It's just an arm of geography. And so for this assumption, I said, for this to be true, universities have to offer strictly geographic information science degrees. Then we had 47 of those, 19% had minors. 12 schools, just under 5% maintained graduate programs, and 27% offered certificate programs. What this means, this distribution where these certificate programs are by far the biggest offering, is that GIS, as it's currently drawn in academia, is a vocational skill. It doesn't, if we have a certificate program, that's basically, anywhere from 3 to 6 credits, 3 to 6 courses. If that's how we draw the lines, that certainly says, hey, this is something you can just pick up on the side and, get a trade skill in and get into the workforce. How it's currently drawn is not in favor of it being understood as a discipline. And this is the biggest hit for GIS or GIS science. Maintains an academic journal, certainly. There are plenty. Number 6. has a community of practitioners and scholars. This, again, depends on how we want to define GIS science. Is GIS science comprised of practitioners, or is it scholars? In other words, is a GIS analyst a GIS scientist? I think most people would say no. Knowing how you can be phenomenally talented in Esri products, and you can go through all the workflows and do a great job, but the reality is if someone said, hey, I want to build a GIS from scratch, what are the problems going to face? A GIS scientist should be able to answer those questions. A GIS analyst likely will not. So, perhaps unsurprisingly, conclude that GIS science is not actually a discipline at this point. And this is really hindered by these things on the right. How can this change? There's a few options. One, we need a concrete definition of what GIS science is. And in 2015, Miller and Goodchild came out and coined the term data-driven geography, which I think is probably a better angle, because it's clearly different than geography, because a lot of geography has been human geography, where it's been hindered by a lot of the sociological constraints in terms of knowledge production. Data-driven geography takes more of a positivist approach, where it looks for objective truths. And so even in this lens, it's not viewed as necessarily a standalone discipline, but it's different enough where you can clearly see where the lines are. The other issue is, who is a GIS scientist? Who is a GIS practitioner? And are they different enough, and do we need both of them? GIS practitioners, certainly. There's a huge need for GIS practitioners. Obviously, right now I work for Esri, so we love GIS practitioners. But in reality, you need very few GIS scientists, or at least as they're currently understood, you need very few GIS scientists. That's an academic realm, a person who lives in a university and is charged with advancing the discipline. But right now, basically, all the GIS instructors, well, I wouldn't say all, 90% of the GIS instructors I've come with have been practitioners who went back to school for a master's or something and started teaching it. So that's something you should be concerned about. There's certainly a need for more generic GIS research. In other words, take one product out of it and refocus on the generic GIS. Refocus on the fundamental principles and issues with spatial data. How do Oracle and SQL handle data differently? I know that depending on how you format your data, you can run into issues where there's certain assumptions you have to make when assuming a point's value. I think the Esri buffer around any point is it's within 9 micrometers of wherever it is where you pointed on the screen. And then the two biggest ones I think is we either embrace or refuse the idea of GIS as a vocational skill. One, are we okay with that? Are we okay with saying, hey, you should be able to become a GIS practitioner after 5 courses? A year of work with GIS, and you should be able to work for any company as an entry-level GIS analyst. Or are we saying, no, that's not the community we want to build? We want to build people who really deep down understand how the technology is working, understand the physics of it, understand the data science, the information science, the computer structure, the IT, the security. Do we want to make these kind of people, or do we want to make GIS analysts? That's a really big thing, and I think it's really important. The last thing is, in 2003, there's a paper called Wither Geography, and it said, if geography doesn't meaningfully show that it's worthwhile in the market, meaningfully show that geographers are good people to have, it's going to die. And so I think that GIS scientists need to do the same thing, because an analyst will probably always be needed, especially with the decreasing, the increasing ease of use and the decreasing, the descaling of GIS analysts, because everything's point and click now. GIS scientists need to make a concerted effort to say, you need us, and prove that GIS science is legitimate and important. And I think that if that comes through, that will definitely be a good thing for the field of study and for the future development of the discipline. So there's a lot there I digested in 25 or spewed in 25 minutes. There's also a paper. It's pretty long. It's about 3,000, 4,000 words. It's more formal in its approach. Obviously, if you can tell, I'm pretty spastic when it comes to presenting. A lot of information at once, and I'm from New York, so I speak quickly, and I apologize. But if you can post your feedback on the associated thread, I really appreciate it. All ideas are welcome. If I said something you don't agree with, you'll say, yeah. Or if I said something that you think's garbage, let me know. I'm not going to get offended. Part of the beauty of this program is you can give people feedback and help them out, because we're all learning and we all try to improve. But yeah, so thank you again for listening, if anyone did. Hopefully this recorded. I didn't test this. In hindsight, I realized I've been speaking for 26 minutes and haven't actually confirmed that my microphone's on. So we shall see if this does work. But yeah, thank you so much.